today we're going to start relating everything that we've learned about angles, the rotation of an angle, and circles and triangles, and we're going to start relating all of that together to circles specifically. We're working towards learning about the unit circle. And this problem is actually going to look really familiar. This is based on what we did that last Friday before school was shut down. That we found out, I think it was Friday, March 13th, that we found out school was closed for 3 weeks. And then turns out the rest of the semester. But this was the lesson that we did on that Friday. And so we're going to go back and review some stuff and kind of wrap that lesson up, so that way we can keep working towards the unit circle and finishing our trig unit. So we are considering a Ferris wheel, a picture of a Ferris wheel. And so what we have here is graphed the Ferris wheel. And we're starting with a car at this position at what would be 3 o'clock. If you looked at this as a clock, this would be 3 o'clock, this would be 6 o'clock, 9 o'clock, and 12 o'clock, obviously. So at this position of 3 o'clock, this is a 0-degree rotation. So what we need to review is the definition of height and coheight. So today we're specifically going to be talking about height and coheight and how they are functions of the degree of rotation. So height is the vertical distance. And coheight is your horizontal distance. So in order to kind of move throughout this lesson, we're going to have to focus on angles that are easy to identify, because we don't have the tools that we need that are currently in my classroom for us to be able to measure angles as accurately as possible. So we're going to do angles that are kind of easy to deal with. So if this angle, so here's our origin, if this angle is at 0 degrees, if we wanted to rotate it to a 45-degree angle, or sorry, a 90-degree angle, this would be our 90-degree angle, right? So then we're going to eyeball that. We're going to split it in half. I don't think I just split that in half. That was pretty bad. Sorry. There we go. This would be then, from here to here, would be a 45-degree angle. So this would be 45 degrees. So let's talk about the 45-degree angle in terms of height and coheight. So if you notice, this 45-degree angle is created using this distance here, this side, the initial side on the x-axis, and this point creates a perpendicular line with the x-axis. So what we have here is a right triangle. And this right triangle has this angle at 45 degrees and this angle at 90 degrees. So this angle would be 45 degrees. Interesting. Okay. So this side of the right triangle here, I'll use a highlighter. This distance right here, this side length of this triangle, is the coheight of this point here, of the 45-degree angle. So this is our coheight because it's the horizontal distance. And then this distance here, I'll use a highlighter again, from the x-axis up to this point that was created by our 45-degree angle using the x-axis as our initial side. This distance right here then is our height because it's our vertical distance. So this is our height. So this coheight is about what, 40 feet? So the radius of this Ferris wheel, I guess I should have said when we started this video, was 50 feet. So then if this is the center of the Ferris wheel, the center's at the origin, this distance is 50 feet. This distance is 50 feet. This distance is 50 feet. So the radius of this Ferris wheel is always 50 feet. So like if you draw the line from here to here, what's that distance? 50 feet. What about this distance? And this distance. So because the radius is 50 feet, all those distances are 50 feet as well. Okay. And then the height is, what is that? Like 35? The height is 35 feet. Okay. So if you think about this point right here, and its x and y values, what would the x value of this point be? Wouldn't the x value of this point be 40? And the y value be 35? Hey, what does that match? So your height is really your y values of the point, and that's created by that 45-degree angle using this side as your terminal side and the x-axis as your initial side. And then the horizontal distance is then your x values. And before we move on to find some more heights and coheights for various angles within this circle, I just want to review the equation of circles, the standard form of the equation of a circle, real quick, and write the equation of this circle for this Ferris wheel. So if you recall, standard form of the equation of a circle looks like this. X minus h squared plus y minus k squared is equal to r squared. And recall that hk is your center, and then r is the radius. So for this specific circle, our center is at 0, 0. Our center is at 0, 0, and our radius is 50. So the equation of the circle is x minus 0 squared plus y minus 0 squared is equal to 50 squared. So x minus 0 is x squared is x squared, plus y minus 0 is y squared is y squared. So y squared, x squared plus y squared equals, and I'm just going to leave 50 squared as 50 squared, would be the equation of this particular circle. And I just wanted to review that, to review equations of circles in general, because for your build a Ferris wheel assignment for tomorrow, you're going to have to write the equation of the circle that represents your Ferris wheel. And so that information is going to come in handy for that. Okay, so now what we're going to do is we're actually going to find the height and the coheight for various points on this circle using these degree rotations. So let's get set up for that. I set my screen up so that way I can view the circle and the table at the same time, which should help us as we try to fill this table out a little bit. So what we're going to do is, the first thing I would like to do is go through and mark all these angles. So for example, halfway through this coordinate plane would be 45 degrees, and then an angle created between the x and the y axis right here would be 90 degrees. Stop it. I'm trying to draw a degree symbol here. Okay. And then halfway between 90 and then the x-axis again would be another 45 degrees. So here I'm talking about this angle altogether is then 90 plus 45, which is 135. So this would be 135 degrees. And then the straight line would be, remember in standard position, we always go counterclockwise. So that's why I'm going counterclockwise. A straight line then along the x-axis would be 180 degrees. Then you'd have straight down. So by straight down, what I'm really talking about here is this entire angle, which would be 270. So then halfway between 180 and 270 would be split by another 45 degrees. So 180 I'm not doing a great job of splitting this in half, huh? Okay, this would be 225 degrees, 270. And then here, so this whole angle then would be 270 plus 45, halfway between the y and x axis again. This would be 315 degrees. And then full circle would be 360. So 0 degrees and 360 degrees share the same spot, technically. Then we're also going to go in, and it's just like splitting these quadrants in half was kind of easy. We're also going to do our 30, 60, 90. So we're going to split it into thirds. So 90 divided by 3 is 30. So we're just going to split this first quadrant into thirds. So like there and there. So then here to here would be 30 degrees. Well, that just went a little nuts. Okay. Sorry. Oh, why does that keep happening? Okay, so this would be 30 from here to here, and then here to here would be 60, and then we have our 90. So just like we split all the quadrants in half, now we're splitting them in thirds. So let's do that over here. So we're just splitting this into thirds. So 90 plus 30 would be 120. And then 120 plus 30 would be 150. This would be 150. And I think 135 needs to move over just a little bit, because that should be halfway between both of those. So should 45, actually. 45 should be halfway between 30 and 60, right? Okay. Then down here, same thing. So we're going to divide this into thirds. 180 plus 30 is 210 degrees. 210 plus 30 is 240 degrees. So just as a reminder, I'm talking about this angle that's created with our initial side to this terminal side. That would be a full 210 degree rotation. Then we're going to divide this one into thirds as well. So this would be 330 degrees. And this would be 360 degrees. No! I can't add. Oh boy, I bet a lot of you just yelled at me right now. Alright, so 270 plus 30 is 300, and then this one would be 330. Because 360 is up there. Okay, here we go. So we've got all of our angles labeled, our 45, counting by 45s, 45, 90, 135, 180, 225, 270, 315, and 360, and then counting by 30s, 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330. So we did basically all the like easy angles that we can make without having to really use a protractor to measure them. So what we want to do is find the height and coheight at each of these points. So remember that this point is creating a right triangle with our x-axis. So our height is the y value of this point, and our coheight is the x value. So it looks like our height would be about 25 degrees. 25 feet, sorry. I don't know why I just said degrees. 30-degree rotation. Our height would be at about 25 feet, and our coheight would be at, I'm getting like 45 feet. All right, then at 0, I guess I skipped 0 degrees. So 0 degrees is where the car starts, and it's this distance right here. This height, this point has a y value of 0, which means our height would be 0. And then our coheight, that x distance, is the radius, so 50 feet. And I just put those in the wrong part of that table, didn't I? I was talking about a 0-degree rotation. Sorry. All right, let's then do 45. So 45 is up here. We're creating a right angle with the x-axis. I got a height of 35. And a coheight of 40. Then for 60 degrees, creating a right triangle, I have a height of 25. No, just kidding. My height is my y distance, so I have a height of 45 and a coheight of 25. Then my 90-degree angle my 90-degree angle creates its own right triangle here with the x-axis. And so its height, the height of this point right here is 50. And then the coheight, it has this point right here, has no distance on the x-axis. It's at 0 on the x-axis, so we have a 0 coheight. So I'm going to help you with 120, and then I want you to find 135, 150, and 180 on your own. So for 120, we are going to create a right triangle with the x-axis. And I'm seeing a height of 45 and a coheight of negative 20. Go ahead and do 135, 150, and 180, and then check back with me for your answers. So for 135, 150, and 180, I got heights of 35, 20, and 0, and coheights of negative 35, negative 45, and negative 50. So let's move on and do all the ones between 180 and 270. So for 180, we already did that, sorry. 210. So we're creating a right triangle with the x-axis here. So it looks like our height is about negative 20, and which is this distance here, or vertical distance, and then our horizontal distance is negative 45. So why don't you go ahead and do 225, 240, and 270, and then check back in with me. So for 210, 225, 240, and 270, I got heights of negative 20, negative 40, negative 45, negative 50, and Coheights of -45, -35, -25, and 0. And to be clear, that just is the wrong screen. That's a 25. All right, so let's do 270 to 360. So we already did 270, so starting with 300. Remember, we're going to create a right angle with the x-axis. So then our height would be -45, and our coheight, the horizontal distance, would be 20. So go ahead and do 315, 330, and 360 on your own. All right, so as you can see, these are the heights and the coheights that I found for the rest of our points in our degree rotations. Let's move on to the next part. So we're going to take all of our heights as a function of the rotation in degrees, and we're going to graph them on this graph here. So we're going to graph height as a function of degrees of rotation. So before we do that, let's go ahead and label our axes. So this x-axis, or the y-axis, sorry, is the height of our Ferris wheel, and that height was in feet. And then the x-axis is going to be the amount of rotation. And that happens in degrees. Okay, so at a 0 degree rotation, we had a height of 0 feet. At 30 degree rotation, we had a height of 25 feet. Why isn't this graph big enough? Okay, so we're actually gonna have to fix this scale, I just realized. This should be a 10, 20, 30, 40, 50. -10, -20, -30, -40, -50. Sorry about that. So then at 30 degree rotation, we had a height of 25 feet. At 60 degree rotation, we had a height of 45 feet. And at 90, we were at 50. Then at 120, we should have been back at 45. At 60, sorry, at 120, we should be at 45. At 135, we're at 135, we're at 35. And then at 150, we're at 20. And at 180, we are back to 0. So we should notice a cycle happening where these, I guess our estimates were kind of rough. These should actually, this should be smoother. This should be a curve. We're going to ignore that point. Okay. And then at 210, we were at -20. At 270, we were at -50. Did we do 300? And then at 330, we should have been at -30. That should be 20. And then 360 is at 0. Because what we want to end up happening is, check it out. We're creating this periodic function because what do you think is going to happen after this point and that Ferris wheel still goes around? We're going to see that same pattern happening, the same curve over and over and over again. And it should be as identical as possible, so it looks like my estimates were a little rough, but we'll pretend like those were all correct, right? Okay, so now go ahead and do the Coheight graph without me and hit pause and then come back and check your answers when you're done. So I know some of our estimations were a little rough, but your graph should look something like this. And again, we're actually creating this periodic function because as our Ferris wheel goes round and round and round, we're creating this Coheight is going to repeat itself over and over and over again. Because can the Coheight or the height of this Ferris wheel change as the Ferris wheel goes round and round and round? No, it's always going to stay the same as long as the Ferris wheel doesn't break, right? So as long as everything stays intact and this Ferris wheel keeps rotating, we're going to see the height and Coheight function repeat itself over and over and over again as we go round and round.